Okay, the next topic we're going to deal with in calculus is trigonometric limits. Now before you start getting all weary and weepy and crying and everything, this is actually not too bad. There is a section in your text that had all those theorems in there. There's one that deals with trigonometric theorems. We're going to go over them as we do some samples here. So let's take this as an example. Let's suppose that the limit as x approaches pi over 2 of the sine of x. And we want to solve that. We want to figure out where that limit's going to be. Now, according to theorem 1.6, in that first chapter that we're dealing with here, right, the section right before these the problems that you can get for your homework, it says that the limit of as x approaches c. Now, when you see the letter c, this is telling you that this is the point that's right next to the point that has x. It's simultaneous, or not simultaneous, but consecutive, yet technically almost simultaneous. And it says if you have the limit of the sine of x at the point at which that you are approaching, that turns out to be equal to the sine of c. So if we keep that in mind up here, then the answer for this is simply going to be the sine of pi over 2. Now you can go ahead and punch that into your calculator, or you can just think to yourself, this is a 90-degree angle, and we know that the sine of 90 degrees is 1. It starts at 0 and goes up to a maximum 1 at 90, and then goes back to 0 at 180, and then goes to negative 1 at 270, and then back to 0 at 360. And there's going to be a chart that I'm going to show you in calculus. You probably may have seen it already. I know scholastic kids see it all the time. But I'm going to spend a little time showing you about trigonometric functions that makes life, so much easier. But anyway, the answer to this is 1. So the limit as x approaches the pi over 2 is 1. Okay? That's sample number 1. Sample number 2. We want to find the limits as x approaches 2 of the cosine of pi x over 3. And again, theorem 1.6 has a little description of cosine functions. And it states that the limit of cosine of x as x approaches c, that is going to be equal to the, or that's going to be given as the cosine of c. Okay? Now in this case, this goes back to one of the other theorems that we had, where if you have, it's called a product multiplier. You simply multiply a value that is multiplied by this. In other words, what I'm saying here is if the limit of x as it approaches c of some function in which is being multiplied, so let's say x times f of x, or maybe it might be better to say n times f of x. That's a better, because I don't want to be confused with saying x there. So say the limit of n of f of x, that is going to be equivalent to n times whatever the function is of x. So you simply take that number and multiply. So we're going to do the same thing here. This 2 is going to go in for this x right here, which is why I put x there. I should have thought of an easy man, but what the heck. This is going to be, the limit for this is going to be the cosine of 2 pi over 3. So that's all incorporated in that. We didn't bring it out like we did with the function because it's all part of the function itself. it's not multiplying the function. So, but the point of this is that you go ahead and plug that in and not worry about any ramifications or changes to the limit. It doesn't have any effect. So again, we put this into our calculator, and we find that the answer to this is -1/2. So the limit of this function approaching 2 is going to be -1/2. And you can always graph these things to see that this indeed is the case, making sure that your calculator is radian, and then doing the whole search with the trace or that other function that you guys found, which was outstanding. You can use that as well. The next scenario says we want to find the limit as x approaches 0 of the secant of 2x. Okay? And in theorem 1.6, this basically states that as we find the limit as x approaches c of the secant of x, then the answer for finding the limit will simply be the secant of c. So we plug the 0 in for the x here, and so we get the limit of the secant of 2 times 0, which is equivalent to the limit of secant of 0. Now secant is the inverse of cosine. So if you're going to punch this in your calculator, you're going to hit parentheses, cosine 0, close parentheses, to the -1 power. Don't hit inverse cosine. That means something different. That is when you're trying to find an angle. That's not what we're trying to find here. We're trying to find the value of the secant. So that is an inverse or a reciprocal of the cosine instead of an inverse of a cosine creating an arc cosine or an inverse cosine. This is different. So this, you punch that in the calculator like this, or you can understand, okay, cosine of 0 is 1, and then the inverse, the reciprocal of 1 is 1. So you do it that way. Either way, you get the answer of 1. But you got to be really careful on what you are meaning as you punch these numbers out in the calculator. Okay? Fourth scenario. The limit of sine of x as x approaches c, according to theorem 1.6, is simply going to be sine of c. So if we have this function's limit of sine of x, where x approaches 5 pi over 6, well, we simply replace x with 5 pi over 6. So this becomes sine of 5 pi over 6. And we could just punch that into the calculator just exactly as it is. Or you can realize that this is almost a 30-degree angle away from the x-axis in the second quadrant, and the sine is always positive in the second quadrant. And we know the sine of 1/2 is, or the sine of 30 degrees, or pi over 6 is 1/2. So the answer to this is just 1/2, or 0.5 as your calculator will say. And the last scenario I want to do with this deals with tangent. And again, going back to theorem 1.6, the limit of the tangent of x as x approaches c is just the tangent of c. So, you can see what's happening here. The one that we aren't going to do is cotangent. It's exactly the same thing. No. So, oh, and we didn't do cosecant either. It's the same thing as well. So in this particular problem, we're going to take a look at the limit of the tangent of x as x approaches. I'm sorry. This is going to be x pi over 4, and this the limit is going to approach x as being 3. So this becomes then the tangent of 3 pi over 4, and 3 pi over 4 is 270 degrees, and so it turns out that the tangent there is, you punch that in your calculator, is -1. Okay. No, I'm sorry, not 90 degrees. That's, my bad. That's not 90. I knew as soon as I said something didn't sound right. That's actually 45 degrees away from the x-axis. That's actually 145 degrees in the second quadrant. That's why it's -1. It's negative because it's in the second quadrant, and it's 1 because the tangent of 45 degrees is uno. So, your practice problems is on page 67, and I want you to do 28, 30, 32, 34, and 36. Have fun!